Hi everyone, welcome back to our next lesson on the distributive property. This is Mrs. Damavandy. So the distributive property has to do with multiplication. If we look at this expression, we have 3 times 7 plus 3 times 10, okay? But if we write it like this, 3 times 7 plus 10, what we're doing is we're grouping everything that 3 multiplies. 3 has to multiply the 7 and it has to multiply the 10, which is really the same thing as 3 times 17. The distributive property is useful because maybe you don't know how to multiply 3 times 17 or don't know what it is, so you can break it down to being the sum of 3 times 7 and 3 times 10. But we're going to use the distributive property to multiply variables and numbers to different expressions. So here are a couple examples where we're distributing a positive number. The first one, we're going to distribute 3 to multiply x and 3 to multiply this positive 3. So 3 times x is 3x. 3, which is positive, times this other 3, which is positive 9. We're done. We've distributed that. We've multiplied it. In the second example, we're going to distribute 4 times a 2. We get 8. And then 4 times negative x. That sign in front of the x affects the x. So this is a positive 4 times a negative x, which is negative 4x. Okay? So again, if you remember from our combining like terms video, the order of an expression doesn't matter. You can have the constants in front of the terms that have variables, but it's the same answer if we put the negative 4x first and then write positive 8, which is plus 8. Same expression, just different order. Okay, let's look at distributing a negative number. So, let's switch colors. Green. Negative 2 is going to multiply x, and it's going to multiply 5. So negative 2 times x is negative 2x. Negative 2 times positive 5 is negative 10, because we have a negative times a positive. Okay? You'll notice me doing these kind of arches. This is just to show what I'm multiplying. It's just a way to show your work. Okay? So let's look at this next example. It doesn't look like there's a number in front of the parentheses, but there really is. That negative is attached to a 1. So we're going to multiply the x and the negative 5 inside by negative 1. So negative 1 times an x is negative 1x. You can write negative 1x like this. You don't have to put the 1 as the coefficient. And we also need to multiply negative 1 times negative 5. Negative times negative is going to make that positive. So our expression is negative 1x plus 5. There's it written with the 1. Or you can just write negative x plus 5. Okay. What happens when you multiply x times x? Well, let's use numbers first. Okay. Let's say instead of x times x, it's 3 times 3. Remember powers. 3 times 3 is the same as 3 squared when you multiply a number by itself. It works the same with variables. When you have an x times another x, it becomes x squared. It means there's 2 x's multiplying each other. Be very, very careful because it's easy to mistake this with x plus x. X plus x is 2 x's. I have 1x and then a second x, which is 2 x's. 2x and x squared are very, very different. So we're going to go to examples where we're actually going to distribute terms that have x in it. So that's why we need to know what x times x is. So if we look at this first example, 5x needs to multiply x plus 1. So, oops, go back. There we go. When we multiply the 5x times this x, okay, The x times the x part is going to be x squared like we talked about. In front of the x inside here, there's really a coefficient 1. So with terms that have coefficients and variables, you multiply the coefficient number parts and you multiply the variable parts. So 5 times 1 is really going to be 5. We multiply 5x times x, it's 5x squared. And then when we multiply 5x times 1, that's simple. Anything times 1 is itself, so we get 5x. Second example, kind of the same thing. Okay, doesn't matter that there's not a number in front of this x inside the parentheses. 2x times x is 2x squared. And the 2x times the 4, which is positive, it's going to be positive 8x. Awesome.